This massive universe is weird and mysterious in its own ways, and we don't even have to look farther for examples. Our own solar system consists of many weird phenomena on different planets. While studying these planets, scientists came to know that Saturn, the sixth planet from the Sun, is even weirder than they thought. This weird planet has been sending some strange signals that have changed scientists' whole opinion about the ring planet. What are those signals? What have they changed about Saturn? And why are scientists amazed? Join us on Techland as we discover the mysterious signals from Saturn. Saturn, a planet that is truly massive and the most beautiful planet in the solar system. It's also home to amazing moons like Titan. It is stunningly beautiful with the rings surrounding it, and these rings are just enough to grab the attention. To know about this beautiful planet, in a joint endeavor of NASA, ESA, and the Italian Space Agency, Cassini was sent to Saturn. Cassini was a sophisticated robotic spacecraft that was sent to study Saturn and its complex system of rings and moons in unprecedented detail. Launched in 1997, Cassini reached the ringed planet in 2004, starting a string of flybys of Saturn's moons after contributing to studies of Jupiter for 6 months in 2000. Cassini has enabled a plethora of new discoveries over the course of more than 125 orbits around Saturn, 67 flybys of its moon Titan, and 8 close encounters with the moon Enceladus till 2011. Surprising details of the planet's signature rings have been revealed by the satellite, as well as incredible water vapor geysers erupting from Enceladus's icy surface. All of this was beautiful, but what baffled the scientists were the mysterious signals coming from the planet. And as Marcia Burton, Cassini's fields and particle scientist at NASA's Jet Propulsion Lab quoted, "Saturn is sending us mixed signals. Mixed radio signals, that is, according to the data from Cassini. The northern and southern hemisphere of the giant planet sent out different natural radio wave signals, which could affect how scientists measure the length of a Saturn day. But the strangeness doesn't end here. Space.com reported that the signal variations, which are controlled by the planet's rotation, change dramatically over time, seemingly in lockstep with Saturn's seasons. Don Gurnett of the University of Iowa, a member of Cassini's team, said, "These data just go to show how weird Saturn is. We thought we understood these radio wave patterns at gas giants since Jupiter was so straightforward. Without Cassini's long stay, scientists wouldn't have understood that the radio emissions from Saturn are so different." Now, Saturn emits natural radio waves known as Saturn kilometric radiation, or SKR for short. SKR is an auroral radio emission that can be detected quasi-continuously by the Cassini spacecraft. It has been shown to respond to magnetotail reconnection and to changes in solar wind conditions. While these waves are undetectable to the human ears, Cassini can hear them like bursts of a spinning air raid siren and vary with the planet's rotation. Cassini scientists then converted the varying Saturn radio wave emissions to human audio range. According to the scientists, they were able to measure Jupiter's rotation rate thanks to observations of this type of radio wave pattern. But the situation at Saturn has proven to be much more complicated. These waves help calculate the day's length on the planet. When the Voyager spacecraft visited Saturn in the early 1980s, the planet's SKR emissions revealed that one Saturn day lasted approximately 10.66 hours. Other spacecraft later discovered that the radio burst varied by seconds to minutes, including the NASA European Space Agency Ulysses probe and Cassini. Now, the problem was that the radio waves coming from near Saturn's North Pole had a 10.6-hour period, while those coming from the South Pole had a 10.8-hour period. In 2010, the study was going on. Gurnett discovered that the southern and northern SKR periods crossed in March 2010 using Cassini data. That is, the southern period has been steadily decreasing while the northern period has been steadily increasing. This occurred 7 months after Saturn's spring equinox, which occurred in August 2009, and coincides with the sun shining directly over the planet's equator. The pattern has continued since the crossover. The Cassini scientists went back over their observations from previous Saturn visits after seeing the strange radio wave crossover. They discovered similar patterns in Voyager's data from 1980 and Ulysses' observations from 1993 to 2000. The radio emissions variations differed from one hemisphere to the other in both cases. The strange radio wave behavior occurred both times within a year of a Saturnian equinoxes. Saturn's equinoxes occur approximately every 15 Earth years, and the next one will take place on May 6, 2025. When Saturn's equinox is viewed from Earth, the rings are seen edge-on and appear as a thin line, sometimes giving the illusion they've disappeared. Scientists were baffled about what was going on there. According to Cassini scientists, the differences in radio wave periods aren't thought to be due to Saturn's hemispheres rotating at different rates. What they thought to be blamed here is the variations in high-altitude winds in the northern and southern hemispheres. Saturn's magnetosphere's behavior is also likely to have an effect. Researchers using data from NASA's Hubble Space Telescope discovered that the northern and southern auroras wobbled back and forth in latitude in a pattern that matched the SKR variations. Another study found that the magnetic field above Saturn's 2 poles changed with the auroras and radio wave emissions over time. Stanley Cowley of the University of Lancaster, a Cassini scientist, said, "The rain of electrons into the atmosphere that produces the auroras also produces the radio emissions and affects the magnetic field. So scientists think all these variations we see are related to the sun's changing influence on the planet." There are 2 schools of thought, said Nahid Chaudhry, a planetary scientist at the University of Lancaster in the United Kingdom. Recently in a research, Chaudhry and his colleagues found that these winds distort Saturn's magnetic field, which alters the timing of radio signals used to determine the length of a Saturnian day. According to Chaudhry, this answers a long-standing mystery. "It's a great ending to a very long and mysterious story," added the University of Iowa's Kurth. "This is the way science works. You see something you don't understand, you put together a model that explains it, and then you go off and make measurements." About Cassini, with the help of which scientists came to know much about the planet, in 2008, its primary mission of exploring Saturn, its rings, and moons was completed. Cassini's mission to Saturn was extended twice after that, and then ended in 2017. Cassini ran out of fuel after 20 years in space, 13 of which were spent exploring Saturn. Cassini was sent on a daring final mission to seal Saturn's fate in order to protect moons that might have conditions suitable for life. Cassini was the closest a spacecraft had ever been to Saturn when it sank into its upper atmosphere. According to NASA, the first taste of Saturn's atmosphere came in the final seconds of Cassini's mission. With the help of small thrusters, Cassini was able to transmit new data about the planet's composition for about a minute while keeping its antenna pointed toward Earth. The spacecraft then disintegrated due to the hostile atmosphere's heat and high pressure. During the final plunge, the ion and neutral mass spectrometer served as the spacecraft's nose, sampling the atmosphere's composition and structure directly. Hunter Waite, the spectrometer's team lead, explained that it's something that can't be done from orbit. Cassini did everything the scientists asked it for and helped them know about the strange and weird features of the ring planet. With new missions in space, scientists are hoping to know more about these signals and the behavior of Saturn. What do you think about the signals? Let us know in the comment section below.